Now, in this question, it says, using the data all values are in kilocalories per mole at 25 degrees centigrade, we need to calculate the bond energies of CC and CH bonds, right? This is actually a question from 1990 IIT JEE examinations. So again, the data which is given is the sublimation energy, atomization energy, then formation of H2O, then combustion of carbon to giving us CO2. These data are given to us. And heat of combustion for C2H6, which is ethane, is given as minus 372, and for propane is given as minus 530. These all values are in kilocalories per mole. Now understand, when we write a combustion reaction, for example, let us say combustion reaction of C2H6, so it has to be in the gaseous form plus O2, giving us what? Giving us twice CO2 plus we have 3 times H2O. We can balance it. This is 4 plus 3, 7. So it will be 7 by 2 O2. Similarly, we can write the combustion reaction of propane as C3H6 in the gaseous form plus O2, giving us 3 times CO2 plus 4 times H2O. So it is 6 plus 5, 10. So it becomes 5 O2 over here. These are the balanced reaction, and all of them are in the gaseous form. This water vapor and everything will be, water will be in liquid form, CO2 will be in the gaseous form. So what happens is, when we talk about the bond energy, so we will have to frame an equation for formation of C2H6. Starting from what? Starting from carbon. So 2 carbon gaseous form plus 3 hydrogen in the gaseous form, right? Should combine and give us what? C2H6. For this equation we have to find delta H for this reaction. Similarly, we have to do so for propane. Once we have those data, then we can take variable. For example, in C2H6 we have carbon single bond carbon as one bond, and we have carbon single bond hydrogen, which are 6 in number. So then what we can do, we can take bond energy of carbon single bond carbon to be X and CH bond energy to be Y. So we have two equations. One set of data will come from what? From the ethane, and second set of data will come from propane, right? So let's do that. So we can see over here in this that the combustion reaction is written. It's a balanced reaction, so we don't have to worry about the balancing, right? So this is a combustion reaction for which delta H is given to us, right? And heat of formation of C2H6 from this delta HR is nothing but summation heat of formation of products minus summation heat of formation of reactant, right? So from there we can find delta HR is given to us. So from there we can find the heat of formation of C2H6, which is twice into minus 94 plus 3 into minus 68 plus 372 on just putting the value. So we get heat of formation of C2H6 as minus 20 kilocalories, right? Similarly, combustion data for C3H8 is given to us. That combustion reaction, the enthalpy change is minus 530, and we can again do the same thing. The heat of reaction is summation formation energies of product minus reactant. So if we do that, from here we get the formation heat of formation of propane, right? So on solving, that comes out to be what? It comes out to be minus 24 kilocalories. This is step number 1, right? Then when we go towards formation of C2H6, it has to be formed from where? It has to be formed from the elemental state, right? The elemental state of carbon is in solid form. So it is carbon solid plus 3H2 giving us this. So for this, delta H we have found is equal to 20 kilocalories. So it is given to us. But this data includes what? Sublimation energy, because carbon will have to convert into twice carbon gaseous form. Similarly, hydrogen has to be atomized. So these data are given. So if we add all this, so we get the delta H for a reaction where we can say that C2H6 is formed from gaseous carbon and atomized hydrogen, and that value comes out to be minus 676, right? The similar thing can be done for propane also, and we get this value. So now we have the delta H formation, delta H reaction of formation of propane in the gaseous form and ethane in the gaseous form, starting from the sublimed carbon and the atomized hydrogen, right? So now, as we know that C2H6, as I've said, C2H6 will contain 1 CC bond and 6 CH bond, right? And similarly, propane is going to contain 2 CC bond, and we can see over here 8 CH bonds. Getting it? So let us assume the bond energy of carbon single bond carbon to be X and carbon single bond hydrogen to be Y. So we can frame two equations from the data that we have calculated. So we have, for the case of ethane, X plus 6Y is equal to 676. For propane, we have 2X plus 8Y is equal to 956. On solving, we get the value X, which is nothing but the CH-CC bond strength, and that is 82 kilocalories per mole, and Y stands for the bond energy of CH bond, which is 99 kilocalories per mole. So we get this as a answer.